Hello, Principles of Engineering students. So today we're going to be looking at projectile motion, which mostly is going to be being able to use an equation for this, so it's no big deal. This is our last thing for the day, our last PowerPoint of the year. So congratulations, you've almost made it. Some terms. So distance versus displacement. Displacement is how far away you end from your up from your starting position. So if we were fired this guy from this cannonball and he traveled up this parabolic path and then landed down here, and the displacement is simply the line from the cannon to his landing position. The distance is the total length of the path traveled, which would be this curve. Okay, we're going to be focusing on displacement. So some other terms to be familiar with. Speed is the distance traveled per time. Speed equals distance over time. Velocity is the distance, speed, and the direction of motion. That is to say, velocity is a vector. This is stuff that you should all be familiar with. And acceleration is the rate of change of velocity. Okay, so it's the change of velocity over a certain period of time. Gravity pulls things towards the center of the earth, and the symbol that we use to represent the number of the acceleration of gravitational acceleration is a lowercase g. And in the metric system, it is 9.8 meters per second squared, and in the English system, it is 32 feet per second squared. So we're going to be focusing on using the 9.8 number in this class. But in the PowerPoint, they focus on the 32 feet per second. So initially you jump off of an airplane and your vertical speed is 0. After 1 second, your vertical speed is 32 feet per second, or 9.8. Okay. After falling for another second, your vertical speed is 64 feet per second, or 19.6. Okay. After 3 seconds, you probably get the hint. Your vertical speed is 96, 128, 161, etc., etc. Okay, so basically that number, that value for g is just how much your velocity changes every second. Okay, so when you fall from a plane, your speed changes by 9.8 meters per second every second. All right, and you don't have to fall from a plane. In this case, we're going to be shooting from a human cannonball. So what's more daring than skydiving? Oh, what could it be? The human cannonball. So a projectile is anything that's moving only under the influence of gravity. Bless me. That basically means it doesn't have wings. And gravity pulls all projectiles down towards the earth at the same rate, and that rate is 9.8 meters per second squared. So some variables that we're going to be using in our equation. There's the firing angle, which is how much the cannon is tipped up. So even with the ground would be 0, 45 degrees, and tipped all the way up would be 90 degrees. The initial velocity is your exiting speed of the cannon. Oh, I should point out that the firing angle is measured in, or is represented by this O with a line through it. It's a theta. It's another Greek letter, so the symbol for a firing angle is theta. All right. So here we're going to fire something straight up, and we fire it up at 128 feet per second. Gravity is going to slow it by 32 feet per second every second until it comes to a stop, and then it's going to speed up at 32 feet per second all the way back down. And if we were dealing with the metric system, it'd be 9.8 meters per second. They're the same number, just converted units. If we turn off gravity, the projectile has a constant horizontal speed. Gravity doesn't pull down. So the horizontal speed of a projectile stays constant. The vertical speed is affected by gravity. Okay. So this is the equation, and Project Lead the Way is courteous enough to rearrange it for you based on what you're trying to solve. But this is the equation that relates your vertical speed, okay, gravity, okay, x, which is your distance, your displacement. See, they even tell you the difference between distance and displacement, and then they use the then they use the word horizontal distance. So it's really the displacement, but whatever. And so then theta is your firing angle. So if you were trying to figure out how fast you wanted to shoot a projectile out of your cannon to land this far away, firing at this angle, then this is the form of the equation you would use. If you're trying to figure out how far away something is going to land, you would use this form of the equation. All they did was do a little bit of rearranging of the same equation. You plug in your initial velocity, your velocity out of the cannon, times the sine of 2 theta, where theta is in degrees. Now your calculator's got to be in degrees. If you haven't had a class where you've had to convert to radians, then your calculator is probably already in degrees, but probably wouldn't be a bad idea to check. And then divided by gravity. Now they put this negative here because they said gravity was negative. So by getting a negative and a negative, you get a positive. Really, we're just going to be putting 9.8 in for minus g. We're just going to be putting 9.8 in. Okay, so an example of using the equation: how far away does the human cannonball land if the cannon shoots in at 30 meters per second at an angle of 24 degrees from the ground? So we're looking for how far away it lands. So we're going to use this form of the equation, which is x equal, because it's already solved for what we want to know. Okay, and other than that, it's just plugging in the numbers. You plug in for your velocity, you plug in 37 meters per second. Okay, don't forget that that's squared. Times the sine of 2 times 24. Okay, and then divide by 9.8. And if you do your calculating correctly, you should get 103.8 meters. That's how far away you land. So give that a go. Make sure that you punch this into your calculator properly, and before you move on to the next one. But we're moving on. The third form of the equation is solved for theta. I guess more specifically 2 theta. So if you're trying to figure out the angle that you need to fire, then this is the form of the equation that you want to use. We've got to use the inverse sine function here, but other than that, it's pretty much the same. So what angle should a man be fired if he is to land 36 meters away if he is launched at 45 meters per second? So we're looking for the angle. That tells us we want to use this form of the equation, and let's plug in the numbers. So 2 theta equals the inverse sine of g, 9.8. Okay, don't let that negative screw you up. Times 36, which is the distance landed away. Okay, divided by v squared, so 45 squared. I went ahead and solved for all this first, and I got 0.174. Okay, then you use the second sine button. You use the second button on your calculator, more than likely. I mean, it may depend on your calculator, but more than likely that's what you'll do. And then so second sine, and then plug in that 0.1742, close parentheses, and then that'll give you 10, and then 2 theta equals 10, so theta equals 5 degrees. So give yourself have a go with that. Try calculating that, making sure you can get the right numbers, and let me know if you have any problems. That's it for the last slideshow. Study for the EOC, and have a good summer.